Get that mousey chachi. Get the mousey chachi. Get it. Where's it? Where's it? Where's it? Where's it? Get the mousey. Get the mousey. Get that mousey chachi. Get the mousey chachi. Get it. Where's it? Where's it? Where's it? Right, I think he's had enough now. Have you let him go? Hey. Right, okay, here we go then. Well, yeah, kind of, yeah, but there you go. Oh, someone's going to have a go about me dusty shelves in a minute, aren't they? It's Trish here. La di da di da di da. Right, there you go, folks. Okay, welcome back. Oh, mind that. No! Hold on a minute. I need to say about that. Let's get everything sorted out. There you go. Should be all right now, shouldn't I? Is that better? There we go. No, I'm only joking. Hey, folks. Right. Okay. We're back, and okay. So we're going to get on with the show, basically. So what you're about to see is, let me just see that. So what you're about to see is the fully edited, raw, live stream video that was originally streamed live to our members back in, where was it, August 2019 or something like that, was it? November 2018. There you go, folks. Of course, the guys that you're going to see were all volunteers that work on the Concorde program. A couple of them, one of them ex-crew, engineers, and so on and so forth. So enjoy this, and then right after that, I'll come back and we'll introduce the edited version, and that will kind of give you an idea of, you know, how we put together the edited, the final edit version, the smooth version. So, but anyway, enjoy it. I'll be there on the comments with you, and just be aware that the bit that you see at the beginning, you don't need to write in the mic's gone, because I'll be. Yep. It's on the own, but you will see that's what will happen. So we had a dropout on the mic, and that was a battery issue on this handset, it has to be said. But anyway, enjoy it, and I'll see you on the chat in a bit. Bye. You are, Jilly. Give me a countdown. Good morning, ladies and gentlemen, and a very warm welcome to Brooklands here in Surrey, UK. And we're very pleased to have some very esteemed people with us today. One in particular, John. John, you're a Concorde lead trainer at Brooklands here. Right. What a fantastic aircraft we have here today. Some history on it.
Sure. Well, the Concorde is very closely linked to Brooklands, and this goes back quite a long time, in the period immediately after the First World War, when one of our most celebrated engineers, Sir Barnes Wallis, was working here with Vickers, and he started to experiment with supersonic flight. Indeed, he built models here which were destined to fly supersonically in 1949. And his concept was that a supersonic airliner needed to have variable geometry wings, in other words, swing wings. That was his concept. Now, that was never taken forward into Concorde, but it was used in military aircraft, for example, the Tornado.
Yes.
But what the other work that Barnes-Wallis did was associated with aerodynamics, in particular in relation to the engine intakes, where the air has to be slowed from 1,350 miles an hour to 500 miles an hour within 11 feet in order for the engines to operate efficiently.
Yes.
So that's a lot of the work that Barnes-Wallis did. Then, as we moved into the development phase of Concorde, the French and the British governments agreed to collaborate in the development of Concorde, and the first meetings of the teams to develop that aircraft took place in Paris and here at Brooklands in 1961. So from then on, a lot of the design work was done here, and as we moved into the development phase of the aircraft, the teams agreed that production of the parts for Concorde would be split between the two teams. Certain bits of all 20 Concordes were built in the UK, and the other bits were built in France. The teams then swapped those pieces to the two construction sites, Filton for the British Concordes and Toulouse for the French Concordes. And 30% of the airframe of all 20 Concordes were built right here at Brooklands. And that includes the 90 miles of wiring that every Concorde contained. So that is why Brooklands has become known, in our view, as the home of Concorde.
So fascinating and so good. Her part here. Did she get...
That's a good question, because she couldn't land here because the runway was too long, and indeed no Concorde ever took off from here, of course. But when Delta Golf was taken out of service in 1981, she was taken to Filton, and she was remaining in the ownership of British Aircraft Corporation, was acquired by British Airways in 1983 and was essentially used for spares. When Concorde was taken out of service in 2003, British Airways gave Concorde to the museum, but she had to be cut into 5 pieces and transported from Filton to here, and over the course of 3 years, together with our team of engineers and a contractor, we put her back together again into what you see today.
And what a fantastic job you have done. Right now, the other... This...
Correct. She was actually the first of the 8 production aircraft. The first aircraft built in each country was a prototype, followed by a pre-production aircraft. Delta Golf was the first of 8 production aircraft, but she never went into airline service, but she did do most of the test flying, first of all to do the proving flights, but also she was the aircraft that did most of the test flying to obtain the certificate of airworthiness. And it was during that phase that she has become immortal, because Delta Golf was and therefore the first aircraft in history to carry 100 passengers at sand. So she's a special Concorde.
Those 100 passengers, were they
was acquired by British Airways.
Yes, wonderful. Well, John, thank you so much. Lightning, I'm sure our viewers would that more Concorde. Who's a flight engineer and what Concorde. Hello there, Ian.
Good morning, Chair. I could just correct you there. Although I had a pilot's licence, I would actually fly the aeroplane. We had 2 pilots, a captain, a co-pilot, and a flight engineer. And because Concorde, when it entered service, it could do an automatic landing, the first aircraft that could do that on entry to service. So we trained flight engineers to fly the aircraft using the automatic systems, and we did this in a repetitive training thing. That was in case of capacitation of both pilots, but that didn't happen.
Okay, well, at least we did that. Ian, just 1 second. We appear to have a slight audio issue. I can see what's just stand by, let me just see. Okay, we're going to go for a check. Okay, just on a check again, Gilly. This is live.
That's good.
That's the beauty of live TV. Okay, we've got full power on the batteries. So, Ian, my apologies. So, you obviously worked on the test program with Concorde, or
No,
not the initial test program.
No.
You're far young for that, I can see.
Yeah.
But you did obviously. What if we have a walk? You were an engineer as well on the aircraft.
Yes, flight engineers had a maintenance engineer. They call aspects of maintenance. If we were diverted somewhere and we could fix it.
Wow! So as well as being a pilot, you were also trained on the engineering side of the
Yes,
aircraft as well.
Yeah.
Wow!
That's the
I see. Okay, Gilly, are you saying that we still have the issues? What is the problem? What is the problem? Okay, interesting. Okay. Is it? Okay. Sorry about this. Okay, so I've got full power on the. Okay, just going to go for a check, Gilly. Going for a check. Are we good? That's more reliable than this.
it's technology.
Yeah, isn't it great? Fantastic. Okay, so I'm now talking. Do we have audio, Gilly? There is a leaf blower behind us that's making a lot of noise. Yeah. Is that leaf blower the problem that's causing the issue? The feedback? Ah, I see. Okay. That's not good. That's obviously no. Okay. Right. I'm wondering if we should. Should we just keep going, Gilly? Okay. So, Ian, I'm going to hand you the mic now. Be careful not to touch that little grey button there.
Right.
If you keep it down there. I'm going to now lift this onto my back. Okay. Little bit Heathrow Robinson. Okay, now we're going to lift this up. And we're going to take a walk. So, Ian, take us around your beautiful aircraft. So, initially, let's start at the nose. Why not start at the nose?
Yep.
I mean, what was interesting was the whole concept of friction and heat. And this nose, right at the tip, was around about, what was it,
127 degrees centigrade. That was the limit. The reason they chose that was that the aircraft was built out of aluminium-based alloys, and to give a reasonable fatigue life, they had to restrict it to that speed so as it wouldn't overheat and then reduce the fatigue life. So yes, the noses, they could reach 127, and if we were cruising along in supersonic flight, if it tried to go above that, if the autopilot was flying it, it would automatically slow the aeroplane down to bring it back to that limit. We didn't often reach that limit, to be honest, but that was the factor involved in that Mach 2 speed.
Interesting. Okay, well that's interesting news there. And of course you've got some deflectors there, so that's just aerodynamic deflectors on the for vortex, I guess, for steering the vortex.
Right. It wasn't a step so as you could clean the windows.
No.
I might add. The reason they had that is when the aeroplane was flying at low speeds, sort of below 250 knots, say, it was to channel the airflow down and make the airflow closer to the fuselage, so as the rudders became more effective. So in low speed flights, say after takeoff, for example, where you need a lot of rudder control, if you had an engine failure, you needed that airflow to be effective round the rudder. So all it was really in low speed flight to make the rudders effective.
Wow, just that small panel there did, it had such a served such
you can
a big
see
purpose.
it sort of tilted down slightly,
Yes,
but
yes.
a lot of development went in to that to make it work.
Yes, of course. Okay, so just moving on now to the undercarriage. Now, one of the big things that is quite apparent when we stand back here is the fact that you are in around about 30 feet from the cockpit to the front, to the nose gear, as they call it.
Yes.
It's not really the nose gear in this instance, is it? It's sort of like the midway gear, but it just resulted in a huge turning circle for the aircraft, especially
if you have a look at the VC-10 just behind Concorde, see where the nose wheel is that compared to the flight deck, the cockpit of that. So when you're taxiing and going round corners and things, you were sitting near the front of the aeroplane. On Concorde, when you come back to this and you see the distance,
yes,
the pilots actually went right over the grass to turn.
Yes.
Or else they...
Let's have a walk over here just so that we can give our viewers a real good idea of what we're talking about here. The fact that yes, you would literally, when you're sort of turning onto the runway, for example, you would be overstepping the grass and
yes. Wow. So that was a thing that they got used to. It's just a different sort of technique. So they were way in front of the nose gear, and because it's so long out there to the flight deck, if we are taxiing on a sort of slightly rough taxiway or even in the runway, if you were down the back of the cabin and looked all the way up to the flight deck, you could see us bouncing up and down at the front of the aeroplane.
Wow.
It was designed to be flexible. If it's all stiff, that causes damage.
Very interesting.
That was a flexible bit of the aeroplane.
Yes. So it was quite a flexible frame then.
Yes.
Wow. And I guess you were mentioning the alloys earlier on. I believe it was Rolls-Royce who actually developed a specific alloy to deal with the high temperatures of friction and.
Well, there was various companies in Britain developed, although it's an aluminium-based alloy, it's slightly different to other materials that were used in aircraft, but it was still effectively low cost or lower cost than going to things like stainless steel and titanium, which airplanes going faster had to do.
Yes.
But so to make it
even so, certain components still had to be made of titanium just to...
Right. The bit you're talking about was really to do with the engine. There was lots of different materials throughout the engine, and
to deal with the high
heat. With the temperatures that it would reach.
Yes. Because it was a jet engine.
Yes, but they used titanium in other engines as well, even at that time. But it was much more strain on this engine flying at these speeds. And really, the sort of about 80–90% of every flight, the throttles were full forward and the engines were rotating at close to their maximum RPM.
For most of the flight?
For most of the flight.
Wow.
And we always used maximum power for takeoff. compared to other aircraft, they work out what weight they are and they can calculate the power they need. So often in other airliners, they use a graduated power system, so the engines aren't fully stressed.
Yes.
Unlike the Concorde engine, we always used the full power. That gave us a better climb-away performance
I see.
from
Yes.
airports and got us higher quicker.
So noticing the how small the wheels are at the front of the aircraft compared to the ones on the main gear, obviously these wheels were subjected to a tremendous amount of heat because the takeoff speed was considerably higher than your average aircraft.
Yes, by the time you go off the ground, you're close to sort of 200 miles an hour.
Wow. And of course, such a high undercarriage, there was a reason behind that, was there?
Yes, the whole undercarriage, the mains as well, had to be off the ground because as you rotated to come off the ground, the front of the aircraft went up and the back of the airplane came very close to the ground. So if you had a short undercarriage, well, the back of the airplane would touch it down.
Yes, yes. Yep. Okay, interesting. So one of the designs that were built into the aircraft with regards to the wing, and in order to keep the aerodynamics as they had been required for supersonic flight, was to actually extend the length of the wing in order to keep the wing a relatively low profile.
Yes, that was one reason. It's a totally different aerodynamics compared to a subsonic wing.
Of course, yes.
There wasn't a sort of aerofoil section that you could describe on like the VC-10 over there. So the shape of it changed quite considerably. You might just catch along the leading edge the way it curves up and down.
Yes, yes.
It's three-dimensional.
Yes, it is.
And like all of these things, the idea was to fly at twice the speed of sound, but you also had to fly slowly. So it did involve compromises, and Concorde had a lot of compromises there. To fly slowly, we didn't have any high lift devices like flaps and slats that you'd find in a normal airliner.
Yes.
We relied purely on this very curvaceous shape of the wing there.
So there were no slats?
Nope.
Wow.
And as we increased the angle, as we slowed down, along the leading edge, it would create swirling air vortices. That you can see the tip just kinks up there.
I'm just looking, getting a good shot of that now.
And these vortices aerodynamically changed the shape of the wing and let it fly. As I say, it's a compromise because the downside of creating lift like that, it also creates a lot of drag.
Yes.
If you create drag, you use more fuel. You need a lot of power.
Yes.
So we didn't like flying slowly. We kept as fast as we could,
Yes.
as long as we could.
Yes.
And well, one thing was the fuel consumption. When we were at 190 knots, say in the outer approach, we were using the same amount of fuel as we did cruising at twice the speed of sound. So the phenomenal increase in fuel. So we did fly slowly for as short a time as possible.
So a lot of that would have been down to the drag.
The drag
the
created.
Increased fuel.
Well, it's these vortices round the wing.
Yes.
You don't get lift without drag.
Yes. Yes. Okay, so let's move on to the underside of the aircraft now. I noticed earlier on, of course, you've got your set of four wheels on the mains.
Yep.
And the actual angle of attack, the flare during landing was quite critical, was it?
Yes, the flare, if the angle went above about 12 degrees, the flight engineer would be monitoring the angle. And if you went above 12 degrees, there was a possibility you might touch the little tail wheel at the back.
Yes.
The bottom of the engines, the thrust reversers. But
I believe there was an aircraft that was actually quite heavily damaged. Not a British one, of course.
No, that's right. Yes, that was in early days. Yeah.
Right. Where they actually touched the
They touched the back and they damaged the back of the engines. They did get it back to Paris, and they did repair it. It went back into service for a short time, but they didn't need all the aeroplanes by that point, so the aeroplane was eventually scrapped, in fact.
What a shame. There were only 20 of the aircraft built.
20, and that included the 6 sort of prototype development aeroplanes. So Air France and ourselves, we got 7 aeroplanes in the end.
Yes.
We were going to 5 aeroplanes,
yes,
but 2 remained unsold, so eventually British Airways effectively inherited them.
Wow.
And of course we put them into service.
Yes.
And we used all 7 of the aircraft.
So tell us about this. This is something that we commonly see on all aircraft, even up to the modern day aircraft.
Yes.
You've got a little bit of a story about this.
Well, this
tell
is
us about what it is exactly.
Well, it's a ram air turbine, and lots of aeroplanes have a similar sort of thing. Basically, a little propeller either drives hydraulic pumps. In the case of Concorde, some drove an electrical generator. We had this really for very bad emergency system, the last resort, effectively, and we could select it from the flight deck, drop it down. That was part of the thing. So if you lost all 4 engines, you needed to maintain control of the aircraft, and we needed hydraulics for that.
Yes.
But we also needed electrics to give us a minimum amount of equipment to be electrically powered. So we had an electrical generator that was powered by one of these little hydraulic pumps, so we could come down. But this was really just to maintain control as long as you could.
Yes. Okay, so that is something that once it's down, it's down. It can only be retracted on the ground.
On the ground, that's right.
I see. Interesting.
We had one aeroplane once that did come down in supersonic flight, but this had never been envisaged, because even losing 4 engines, you'd only resort to using this because engines would be windmilling, still giving you hydraulics and,
yes,
and that. But when you come subsonic, then you pop that down. But this came down supersonic flight, and they were a bit concerned as to what might happen if it would fall off or something. But in actual fact, it's robustly built, and it was okay.
Yes, it withheld, and it's got a sort of like it's got an aerodynamic leading edge to it anyway. The actual arm itself. So
that's right. And just up inside, it's just a shaft that goes up, and it just runs into 2 little pumps.
If anything, it's actually the doors that are the most unaerodynamic piece of it.
That's right. Yeah.
Okay, so just moving on to the I guess you'd call them the cowls, would you? The engine covers, these. Well,
the whole thing is a nacelle.
Yes.
At the back here, we've got the nozzles that are when you swing right round, and it reverses the thrust. So the jet air thrust comes out the back of the engine, and it's redirected, like the engine over there.
Yes.
The number 3 engine, and it pushes the thrust forward and gives you braking. Normally only used, always used on landing for stopping, all 4 of them.
Yes.
But because we didn't have any sort of high lift devices or spoilers that you have in a conventional aeroplane, we could, below 30,000 feet and 370 knots, we could reverse the 2 inboard engines to act as a braking system as well. So if we had to descend quickly, it was just acting like a speed brake.
Interesting.
Spoilers are like speed brakes.
Yes, yes, of course.
But we didn't have them.
So as we step back here, we just get a great look at the, of course, the tail. So impressive. Such a huge tail. And obviously that's the housing for the stabilizer there. The horizontal segment is the housing for the stabilizer, and what, of course, people will notice is that there is no tailplane. No tailplane per se.
No. So the wings and the controls at the back of the wing did both pitch control and roll control.
Yes. Just get a really good profile of that wing there. If we can move round here. That's a good shot there, isn't it? Yeah.
Yes, you can see how thin the wing was and how curvaceous it actually is.
Beautiful.
And it had to be like that to create this sort of vortex lift.
Yes. Yes, because that was the they were all the the sort of physics that people were dealing with at those times, that they were sort of still in their early stages of understanding, I guess.
Oh, the number of different ideas to try and make a wing that would have this compromise for supersonic flight and low-speed flight. And you see how thin the wing is at the outer part there. That's actually a fuel tank as well.
Is it really?
Because each
right out
wing
on the outer leading edge there.
Yes, from where the control is underneath that powers the control surface. All that wingtip contained 2.5 tons of fuel, each wingtip. So the designers did an amazing job to pack so much fuel into this.
They certainly did.
Which is really a very tiny aeroplane with a lot of, little tanks, 13 fuel tanks in this thing.
Goodness.
And if you look up at the tail there, from where you see the tail wheel, the forward end of that bulkhead is the back bulkhead of a fuel tank, and it goes forward to roughly where the G is in the registration.
Really? That's a
that
tank
held 11
itself.
Tons of fuel.
Did it really? So your CG was something that was quite critical then in terms of load.
Yes.
Because obviously with an aircraft of this type,
as the airplane accelerates, the centre of lift moves rearwards in the wing, so we had to trim it.
Yes.
If we tried to do that with the control surfaces at the trailing edge of the wing there, they would be in a very uneconomical high drag position.
Yes.
So what we did, we moved fuel to alter the centre of gravity, so it just matched the centre of lift movement in the wing.
I see. Interesting. Okay, and just finishing off right at the back with which I believe this was a skid initially on the initial aircraft, and then they changed
the very first one was a skid, and then the next one had the little wheels and it had this concept. It's not in the ideal position on the airliner because the original aeroplane, the first prototype, it was shorter than this, and they had the top of the fuselage curved down and the bottom curved up. But as you can see here, the top of the aeroplane is flat and it's only the bottom curves up.
Yes.
So obviously the rear wheel moved up a bit.
I see. So how often did you actually use that then? How often?
Very, very rarely. The very odd occasion you'd maybe see the little wheel marks as it rubbed across the sort of concrete. But that was always, as far as I recall, if we're training new pilots, but in service, no, it would be mainly on landing that would happen, and as I say, the flight engineer would be monitoring the attitude of the aeroplane.
I see. Okay. So the flight engineer is obviously in touch with in communications with the pilot, and he's telling him to give it a little bit more, pull the nose down a little bit, to reduce the flare.
All we say is attitude, and they would de-rotate the aeroplane.
Right. Yeah. So you've either got good or bad attitude.
This is true.
Yes. Okay, let's move over to the engines, of course, extremely famous. It's the Olympus.
Yes, the Olympus engine. Originally, the Olympus was used in the Vulcan, the bomber.
Yes.
But the TSR-2, of course, as well. But this is a vastly developed engine compared to these engines. The original engines, I think they developed maybe the very first one's probably about 12,000 pounds of thrust, and then they gradually increased to 20,000. We produced the straight engine without the reheat or afterburner was 30,000 pounds of thrust, which was pretty high. But the reason they chose this engine was that in supersonic flight, a jet engine will only accept a supersonic airflow up to about 1.5 times the speed of sound. Then the airflow in the intake gets so disturbed it starts banging about. We call it engine surging. It's like backfiring.
Yes.
So
okay.
What happens is we had to slow it down. So we had this intake in the front to reduce that. because we wanted to go faster than 1.5 times the speed of sound.
And this is the intake here that we're talking
Right,
about.
so this is the intake.
Yeah, so this is what Barnes Wallis was involved with in terms of in terms of slowing the aircraft, the airflow down.
Well,
was it?
there was a lot of aerodynamic research went on throughout the sort of companies involved in Concorde, and of course at Farnborough as well. And they came up with this idea to slow the airflow down. The large doors in the roof of the intake, you see the ones with danger, but there's another door just behind that.
Yes.
And they are lowered under computer control. And they create lots of shock waves with the intake. And the series of shock waves are focused on the bottom lip of the intake there. And as the supersonic airflow goes through that series of shock waves, it slows it down. So in 11 feet of intake, it goes from twice the speed of sound to half the speed of sound.
Wow.
So an amazing
section here.
Yeah. From the front of the intake to there, it slows it down.
Just where the Rolls-Royce sign is.
That's right.
Wow. That's an incredible feat of engineering.
And not only that, the intake in the cruise and supersonic flight, that gave you 70% of the thrust of the whole propulsion unit. 70%. The nozzles at the back, where we looked at earlier for thrust reverse, for landing and that, they opened up wide in supersonic flight, and they gave sort of about 18-20% of thrust. The engine only gave about 8%.
Wow.
But there was a whole concept.
The aerodynamics themselves were what actually pushed the aircraft forward into. Wow.
So the whole
this
concept.
Has just got it going, really.
It was all, each part relied on the other. But
yes. How interesting.
It was a tough old engine there, and as I sort of briefly mentioned, we reheat too. Now this was a thing normally only used on military aircraft.
Yes.
And we needed this because for the thrust we required on takeoff, it would really have meant we had to carry an extra engine. But once you didn't need it, then you're carrying all that weight.
Yes.
So we resorted to the reheater after burning. And all it really was injecting fuel at the back of the engine, lighting it up, expanded the air a bit more and gave us the extra thrust. So it sounds a good idea. It did give us a thrust, but it used a lot of fuel.
Yes.
The fuel consumption was really very high, as it always is with reheat. And if you close into the back of the thing there, we sprayed fuel in.
I see the nozzles
in this round here, and the flame attached to this gutter, they called it, and that held the flame alight and working for the reheat.
Which is the famous shot that people have seen on
the
videos
flames coming out the back. You see these diamond shapes in various aeroplanes.
Yes.
So each bit of the sort of propulsion system relied on the other.
Yes,
so
of course.
It was an amazing concept.
So it all worked in unison very effectively. Fantastic. Well, Ian, we've, I think, finished our tour of the outside of the aircraft.
Right.
And we're going to go on board now.
Yes.
I believe we have sort of like hybrid, so to speak. It's half the actual... The testing equipment, some of the testing equipment, and some of the cabin to show us. Okay, fantastic. Let's go.
Okay. Well,
so as we walk up, we can just have a look at these reverser buckets.
Oh yes, that's a good idea. Yep.
If I go up here, I can. There we go. That gives us a clear shot across the wing as well, so we can get...
also underneath. And that drew in air that diluted the airflow coming out of it.
I see.
And allegedly reduced the noise of the propulsion system.
Yes.
But when we became supersonic, these nozzles would open up right wide to their maximum.
So even beyond that, they would expand beyond that.
Yeah, and that,
I see.
And that was, if you think of a rocket motor, you've got these sort of nozzles, if you remember the space shuttle.
Yes.
So that sort of looked a bit more like that, opened up.
I see. Wow, interesting. Yep. So here we get a really good idea of the wing profile as well, right up to the front of the aircraft. Tiny little windows, of course.
Yes. We'll see these inside.
So was the expansion? I know quite a lot of talk has been about the expansion of the aircraft in flight. The expansion and shrinkage back
Yes.
to. Is that something that was a problem in terms of the panelling on the aircraft at all?
Not really. Well, they obviously knew it was going to expand, because if you heat anything up, it's
Yes.
going to get bigger.
Yes.
And they reckoned it got 10 inches longer in supersonic flight. I don't know if anybody actually got out and measured it, but yeah, it obviously expanded. And when they built the interior in that, of course, the interior is all air conditioned.
Yes.
And that doesn't expand.
Yes.
But the outside does. So throughout the cabin, there was various sort of points where there was effectively expansion joints. The various units were built on sort of, suppose you'd call it sliding rafts, and it was all trimmed over. You didn't see anything. But when we go in the flight deck, I'll show you where you would see the thing. The only bit in the aeroplane you saw this gap opening up, and
Where
that's
we've
just in the unit.
famously seen that captain's.
Yeah,
hat
somebody
left in there.
stuck a hat in there. Yes.
Okay, let's go. Let's go.
Right. This is the rear cargo door.
I see. Okay.
So
she carried cargo through here.
Yes.
When we say cargo,
well,
we're talking
baggage,
the baggage,
and
yes.
usually high value goods we carried in here.
I see. Okay,
So-
diamonds and things.
Yes, the odd one. So this was all the cargo hold here.
Wow, okay.
And that's the bulkhead. The other side of that is that big trim fuel tank.
I see. I'm with you. Yes. There's the bulkhead, and that's the fuel tank, and this is the cargo hold.
Yeah, and this part here is where the galley would be. So the galley was in this section. The rear doors were in the galley area, these doors, and then we would go into the cabin area.
Okay, so this
there.
is where the passengers would come in
So,
through here.
well, no, that was only used for an emergency exit
I see,
and to load catering.
Yes, I'm with
So
you.
the
yes.
front left
Because it's
door
over
is
the
where
wing,
the
isn't it?
passengers
It's
come in.
actually over the
Yeah.
wing. So the front doors are obviously for the passengers. Yes. So we're seeing a piece of the exposed airframe here without the coverings.
That's right.
It's quite interesting.
So you, if you can get a close-up, you'll see the technique of machining these special aluminium-based alloys was, instead of riveting sort of ribs on, they had a big billet of metal,
Yes.
and they milled away the unwanted material.
I see,
So
I
the
see.
huge bits of metal, a big sort of forgings produced,
Yes.
and this new technique of machining, computerized machining, to produce these little individual things.
I see.
Then at various
right,
points,
yes.
skinning and increased
Yes.
frames were put in.
So a new, so new techniques of manufacture were actually brought forward when Concorde was manufactured as well.
Teflon coatings, use of lasers and things like that, all
Interesting.
come into being.
That's great. That's great. Wonderful. Okay, so moving forward.
Well, this is the rear cabin up to the bulkhead you see up there.
Yes.
And what they did was, although this had passenger seats in it for the development sort of stage and route proving and things, when it came to the museum, this was really just a shell. So they decided to put certain things on display. Along the top edge there's a little sort of timeline telling you the various aspects of how they developed Concorde. And then they've got various little sort of artifacts and things on display.
Yes, yes.
And also in here you see the little TV monitors there. So that tells a story of supersonic flight, the development done, the things, the procedure it went through, and then it shows you the video of how they actually got this aeroplane up from Filton. They dismantled it. They actually cut it up and then brought it on various trucks here. And the company, they've done several aircraft. They also did the one that's up in Edinburgh. So the aeroplane was reassembled here, along with lots of companies involved. But there was a big team of enthusiasts, volunteers that came in and put this all together, which was an amazing achievement. One chap to mention, he works for a company, and he was so enthusiastic about this, he actually managed a lot of this. He was his team leader.
Oh, right.
And he also did the simulator as well.
Oh, okay. So, really keen, a real keen enthusiast.
Oh, yes, so talented.
Yes.
But yeah, Gordon, he was a very enthusiastic person, still is.
Okay, so that's quite interesting. There, that's obviously the wind tunnel testing as well.
Yes,
which is again, I would imagine that they probably built wind tunnels specifically for the testing. Did they, or
yes.
Did they use existing wind tunnels? But because of the needs for the different aerodynamics, they maybe had to develop new.
Well, there was a lot of wind tunnels. The main ones were at Farnborough, and they did a huge amount of development on these wind shapes there. They did have a supersonic wind tunnel here, but it was really quite small. It wasn't as sort of large as that.
As the vortex that you were talking
and
about.
that's exactly it.
It's very, very interesting.
And all that sort of swirling air, that's creating drag as well as the lift.
Yes. So it's a fine line between the two. You have to balance it out.
Absolutely, yes.
Okay, so we're moving forward now. Now, was this the headgear that was actually used by test pilots, or? Well,
during the testing of the aircraft, of course, this was a new thing, and you're getting something that's been so many years in designing and development. They're going to take all the precautions they can. So yes, okay, they used these various things, special sort of flying gear and stuff.
Very Americanized, that, isn't it?
Absolutely.
Interestingly as well, we discussed earlier on, John was mentioning about the length of wiring looms that were used on each aircraft. Was it, how was it, 9 miles or something?
Or something like that. He mentioned it earlier.
Yeah.
But you can see all this wiring, how tiny it is. Absolutely amazing. Very tiny. You can see a small insulation is.
Very fine, yes.
And they were, of course, all identified with codings and that all connected up.
Each individual wire served a purpose.
Yes.
So you got some lovely models.
These are the airlines that were going to buy Concorde.
Yes, of course.
But when things started sort of going wrong, the fuel crisis in '73, prices rocketed.
Yes.
And of course, United States, Boeing, they decided they weren't going to go ahead and build their supersonic aeroplane. They were wanting to go much faster than us, and it was going to be hugely expensive. They changed, so the competition disappeared, so a lot of these airlines decided they weren't going to go to the expense of it. So it just came down to Air France and ourselves.
Yes. Great shame.
Yes.
Great shame. But there you go. That's
the market.
That's the way things work out. So some memorabilia here, collectibles.
Yes, on scheduled flights, the passengers were presented with a little specially commissioned gift. And that on the charter flights we had as well, the passengers would also get a special gift. It was a very nice plastic model of a Concorde, really nice.
Lovely.
If I can draw your attention to this,
yes.
I mentioned the intakes, the computer control.
Yes.
Now, when Concorde first flew, they didn't have intakes working. They were under development, and what they found was analog computers wouldn't be able to control the intakes.
Yes.
So this is actually a digital computer. If you look at all the cards, all hand assembled things, you compare that with technology nowadays.
Oh, it would be the size of a grain of sand or a grain of rice. Literally, you could get all of that.
That was it. it was the first case of digital computers
Yes.
being used in an aircraft.
Yes.
Now, there were other aeroplanes looking at digital computers. For example, the TSR-2, they were going to build a head-up display, and that was before that, but of course nothing came of that. But this was actually used.
So we'll be able to see that panel on
And
the
you'll
flight
see the
deck
panel.
in a
That's the
little bit.
panel there, that
Yes.
bit.
Yes.
But you'll see that on the flight deck.
So a critical part of the actual aircraft performance was the air intake.
Yes,
Okay.
So as we come forward, these are instruments.
Yes. Artificial horizon.
Yes, you'll see the technology involved. It is a mechanical instrument, although it's got lots of electrics.
Yes.
Compare that to modern aircraft.
Yes.
We'll talk about it.
But the good thing
later.
is that even in modern aircraft these days, they still have a
Yes, there's a backup.
digital version. Yeah,
But
they have
not all
a
of them.
natural one. Yes.
This was a section of the tank liner they fitted for the modification to get it back into the air.
Yes.
That was it there.
And that's them. That's them constructing
That's
it here,
them
isn't it?
assembling it here. Yes.
Assembling it here, yes.
And
great.
this little aeroplane boom, well, they're developing a much smaller aeroplane, but it would fly at the same speed as Concorde. And they're going forward, getting backing in that, and hopefully that'll be
Hopefully
in
that will.
service
Yes,
someday.
most definitely.
This little section.
A little bit of cabin here. Now these are onboard computers, I'm guessing. For,
Right. Now, this was only for development thing. This is an
Yes.
example of what they carried on other aeroplane, the other predecessors of this particular aeroplane.
Yes.
So there's banks of these huge recorders. Look at the size of the discs
Yes.
to get the data.
Yes.
So you can see this was a long time ago. This
Yes.
is old technology.
Most definitely. And again, that one particular unit there would be about that big.
Oh yes,
Now,
absolutely.
just tiny.
Yeah.
Which is just, it's great to see technology move on like it has.
This section here, this is an example of the various seats, the interiors that Concorde had in British Airways
I
throughout
see
the
the
years.
different,
So
different
over the ages,
fit-outs,
the
yes.
one at the front there, that's the original one. The
Yeah.
actual material here is not actually correct. The material was a striped sort of thing, a bit like a deck chair, to be honest. The only place that I know where they've actually got an example of this is up in Edinburgh,
Right.
at East Fortune. So through the ages, this is what we had originally, and that was quickly changed, at the end of the 70s. Then we went to the 80s, and then on the other side went to the 90s. And at the very back, the blue one is the one that they were beginning to fit to the aircraft to go back into service
Right.
after
I
the Air
see,
France
yes.
thing.
Yes. Okay, so that's the most up-to-date and recent one that they were
Yes.
planning to use.
Uh-huh.
Okay, right. Moving on into the. Okay, so now we're in the. Now we're actually in the cabin.
So this is the forward cabin. We didn't have different classes. In the aeroplane, front was the same as the back. There was
Yes.
no fare difference or anything like that.
Yes.
And here you can see the example of the seating. It was a small aeroplane, but what people forget is when Concorde was being designed, we hadn't seen a 747. We hadn't seen a wide-bodied aeroplane.
Yes, of
so
course.
we're looking at things like a 707,
Yes.
DC-8s, that
Yes.
sort of thing, and of course smaller aeroplanes. But it had to be this size. It couldn't be like a jumbo jet to fly at these speeds.
Yes, I think. I mean, to be honest with you, even though it's not overly tight in here, and the legroom is just exceptional. That's the one thing that really stands out.
Well, the aircraft was licensed to carry 128, not
Yes.
100. But we only ever put 100 seats in it because that suited the market best. And of course, it was a premium product, and you wanted to give it at least decent legroom. we did do.
I think in the late 80s it was still about £7,000 for a one-way to New York or something like that.
Well, there's all these things. I could write a book on these different ideas that people come up with.
Yes, yes.
The fares did change throughout the years. I think a better way of comparing the cost of flying in Concorde was it ranged between, well, virtually the same as a first-class fare on a subsonic aeroplane,
yes, yes.
only for a short period, I might add, to up to 20% increase. But it was always an increment on top of first class. But that fare did vary.
Yes,
you know,
yes.
it was altered to sort of fit the market. If the load factor dropped, then we dropped the price. If it went up, we increased the prices.
Yes.
So it was very well managed. Within the Concorde fleet, we had a separate Concorde division set up within the airline. So we were, you know, separated away. That eventually came into effect in about 1980.
I see. Okay.
And
okay.
That was managed by two of the pilots that were on the fleet.
Okay, so we're walking through there now into coming up through past where I'd imagine the galley is, would it be?
Yes, this is the front galley.
Yep.
And we've got the toilet here, which I might add, we didn't have a glass door on the toilet in the real aeroplane. But this came in round about the mid 80s, and
still a decent size.
This was a new thing. We had electric taps. You just pressed an electric button, so that was quite a novelty.
That is a novelty for those days, isn't it?
But you see, it was quite compact up here. But
yes.
You can see the aeroplane; it's reducing in height as we go forward.
Yes, yes. Okay, so we're now going into the flight deck, and we are meeting up with James.
With James, yes, James is up here all ready for us.
Okay, let's just.
And you see, as we come in here, this is where all these electronic boxes were. If something a system wasn't working right, it was a easy problem.
Switches and
we
stuff like
could
that.
pull this off and change the appropriate black box.
Okay.
Get it working.
Well.
And these are circuit breakers, fuses.
Yes.
So.
Okay, fantastic.
Here.
So, James.
Good morning.
Good morning to you. How are you doing, sir?
Oh, well, I'm here now.
So you actually are responsible for putting it back to operational.
Yes, I started in 2012. It took 4 years. Got it working in June 2016 for her 10th anniversary of her opening, and then it's been operating ever since. Hopefully she'll work today. One of the micro switches is being a bit, so hopefully she's being okay today. So we'll see.
So what is the normal procedure then?
Right, on this
it is a 3-stage, is that right?
Yes. So on this aircraft, because of her history, she's missing a few bits. The procedure for this specific aircraft is slightly different. That we have to pull the emergency release handle to get the nose down. But shall I just go through it now then? Shall I start?
Most
right,
definitely. Yep.
So first you need to turn hydraulic pressure on, and then it works as per it should do from the normal nose and visor selector valve.
So the visor's coming down now.
Yep, that goes into the nose.
Yes.
So I cycle it a few times at each section just to push some new fluid through.
He just likes playing with it.
So yes, at this point, normally when the visor goes down, I'd be able to just go to the next section, which is nose 5 degrees. But on this aircraft, I have to pull this handle, which is not normal operation, and then the nose comes down.
And the nose will drop.
Yeah.
And from
do you want to bring that up again, and I'll nip down and get it?
Yeah, no, we'll take it all. If you want to stick your camera down there,
if you got there, you'll see.
That's going to be difficult. Oh, that's going to be quite difficult, I think. Let's just have a little look. Okay, just stand by. Okay, yep. So that's the nose lowering now. You can feel it going home as well.
there should be a nice click. Sure is.
Okay.
So this is the point where she was misbehaving, and she's working this morning.
Oh, perfect.
There we go.
Wow.
Yeah.
So, Ian, once that was in position, you knew you were sort of like on your way, so to speak.
Oh yes.
So, at what point was that? Was the nose raised? Was it how long after takeoff?
Well, we had to comply with various air traffic instructions and things.
Yes.
But if we went above 270 knots, that's 300 miles an hour, then we streamlined the aeroplane. We put the nose and visor up, and it became fully streamlined. And then, of course, as we slowed down through 300, we put it all down again.
Yes.
So we went to the mid position, as James had mentioned there, 5 degrees with the visor down, and then just before landing we'd pop the nose fully down. So 5 degrees was the mid position, and fully down was 12.5 degrees.
Okay.
And as you saw when it was down there, we probably picked up in the camera, the pilot sitting up in his position, he'd have a clear view of the runway.
Yes.
It wasn't obstructed or anything.
Yeah, and the main reason for the nose was a visibility thing, wasn't it?
Yes.
So that at the pitch, at the actual flare, the pitch of the aircraft,
Yes.
angle of attack, so to speak, you could, because the nose being pitched forward, you could actually see beyond it.
Yes. Well, the sort of final approach, but the pilot would be flying about 10.5 degrees. Nose up attitude, so you wouldn't see over the nose.
Yes.
If you think of the older fighters or Spitfires and things like that, when they're sitting on the ground, you've got this big nose in front of you.
Yes.
It'd be a bit like that. You just
Yes.
wouldn't see where you're going.
Yes.
So they needed to invent this, and that was all designed here at Brooklands. They come up with this idea and got the configuration. But you can see that with all this curvaceous shape and the streamlining to fit in with the rest of the aeroplane, quite a challenge to make it all move like this. And James does a great job getting it to work like this for demonstration.
It fits like a glove, literally,
It
doesn't
yeah,
it?
Yeah. I would like to add, he hadn't cleaned the windows there.
No, brilliant job, James. Thank you. And you must be proud of being part of doing that.
Yes, it's I've been in there soldering wires, fixing stuff in -1, -2 degrees, but it's
Goodness me.
rewarding that on the day when we can show her off that.
So how did you
Yeah.
actually come to offer your services to do this then?
My dad, before DG arrived on Concorde's final flights, he started to take me up to Heathrow, so we'd see her on the final July, August, September, October, November period. We'll go down to Heathrow, and then we met up with a chap called Gordon Roxburgh, who is our Concorde team leader, so to speak. And then we all got involved when I was 14 years old down here when she first arrived, so I was here when she first arrived. Then I got involved with the volunteer team, so I've been here 15 years next year. And then in 2012 I did my university dissertation on what would all this system look like in the modern, if it was done now today. And then we thought, well, why don't we make it work? So from that point onwards, for 4 years, I started fixing it. I had to work out a brand new wiring diagram for her because we don't have the wiring diagrams for her. We had to recreate some of the hydraulics.
Wow.
So essentially, yeah, it's 4 years of my life to get this thing.
Wow,
working
fantastic.
again, so.
It's your baby then, isn't it? Really?
Well,
He produced some great diagrams and drawings,
I
far
bet.
better than we ever had at the beginning.
It's incredible. And you actually had to design and develop revised hydraulic program
it's
systems?
because this nose fairing actually came off the one at Filton, so there was an accident at Heathrow. So DG donated her nose, the one that's now at Filton, and this is the one at Filton. But it was halfway through being refurbed when she stopped flying. So all the systems in the movable part of the nose down there wasn't wasn't there, so we had to effectively recreate all of that. Everything in kind of the fuselage structure, so everything under the floor here,
Yes.
was still there.
So
that
there
just
is
needed overhauling.
So there is a considerable amount of hydraulic pumps and
Yes,
moving
so
parts
there is-
underneath here.
There's a hydraulic pump under the floor there.
Yes.
It's not, so it plugs into where the original hydraulic supply would have come from the engines.
Yes.
And then it works almost as it should. Once we've got the two parts that are missing, then it'll work 100% like it should.
Well, it seems to be working today. So should we nip outside?
Yes.
Ian, and check the operation one more time.
I believe
Thank you so
Roger
much, James.
has joined us next.
Yes.
Shall we?
Well, we'll introduce you to Roger when we
Right.
come out.
Okay. Righty-ho. Still backing up. Diddle-it. Hello, sir.
Hello.
You're Roger.
Yes.
Nice to meet you, Roger. I'm Jerry.
Jerry.
Very nice to meet you. So tell us about yourself then, Roger.
I'm a volunteer down here. 45 years of British Airways, licensed aircraft engineer on the Concorde and some subsonic stuff. One of the team that come down here on a Wednesday particularly, and we look after, maintain, try and improve the aeroplane.
Wonderful.
Yeah, all the little projects we have are for the benefit of customer information and
Yes.
improve what we offer to them.
And it must be good to you. Obviously, you've got thousands of people coming through the gates every year. Just educating them on Concorde, because obviously a lot of people know about Concorde. There's a lot to learn about Concorde online, but to see it in the flesh and actually learn about it from somebody who's qualified on the aircraft as well must be fantastic, as it is for me.
It is, yes. We do get a lot of people asking questions and put to bed some theories that aren't quite right.
Yes, right.
As I previously mentioned.
Okay, well, we're going to nip down the steps now, and we're going to get a quick look of her at the nose being raised and lowered again.
Okay, with you.
Okay. Let's have another go. He's opened the window. You up there, James?
You ready for us?
Okay, get that visor up, sir. So now we're going to see the visor up. This is the... Okay. Is it going to fail on us today? Okay. So at this point, this is where, at what point would the visor be down?
We always did it together. So we did the visor went down, and then we selected the nose 5 degrees. We didn't fly
That's
about.
the nose
we
5 degrees now,
So that's
is it?
5 degrees now.
Okay.
Yeah. So that's 12 and a half. The original prototype, that was about 17 degrees it went down, but we didn't need it that low.
Right.
So it was then limited.
So that is at its fullest now?
Yes.
Wow. That is so impressive. And up she comes. So it would be always in those 2 increments there.
Yes.
And is he going to get the visor up?
It was playing up.
Yeah, he did, didn't he?
If it doesn't work, it will give them something to do with.
Yeah. Yeah, I think it's a
It might be stuck.
bit like our equipment.
Yeah, he switched
Yeah, he
off.
switched it off. There we go.
Can I just make one observation?
Yes, sir.
You saw how cramped it was up there in the flight deck.
Yes.
And under the floor, there's lots of different. There's guys like Roger here. They did the work on Concorde. Everything was cramped. It was all a big sort of fiddle. And you can see, you know, I'm really quite small here. But
Well, some of the access was, like Ian says, was through the flight deck floor. The seat had to come out, the engineer's seat particularly, which was a bit of an art in itself. But other access was underneath, because there were relay jacks, one on top of the other. The same with fill jacks and some were access on top, some were underneath, and some were between two panels. It was an interesting aeroplane to work on.
And when you say those sorts of tasks and procedures, is that something that's once the aircraft comes back from an operation, from a flight, are there certain regular procedures that need to be checked, or
No.
is it periodical?
It was periodical, but mainly they were defects. Bear in mind that it was a fly-by-wire aeroplane, so that most of the time we dealt with the mechanical backup system, which the crews rarely, if ever, used. But they were the systems that gave us, if you like, the problems. The fly-by-wire side of it was actually very reliable, very good.
Was it really? Even though it was quite, it was very early stages of fly-by-wire, wasn't it?
Well, yes, it was. But for instance, setting up the flying controls, you had electrical systems, and then there was a mechanical system. Well, if anything happened, the changeover between the two had to be seamless so that the flying controls didn't kick. And rigging those flying controls to go from blue to green to mechanical was, yes, it was. There was a challenge. There was a thing on the PSUs called the Messerschmitt thread, and the adjustment of which was tricky.
Yes.
It was something that had to be experienced to believe it. It was good. The aeroplane was actually very good. The air conditioning system gave us a lot of problems, but there again it was a very hard work system, because today you have to heat people up. As it climbed up into Super Cruise, they'd want to be cooled down.
Yes.
When it got to New York, they had to be warmed up again. So the system was hard worked, and we worked hard on it.
So the air conditioning on modern jets these days is used, is bled from the engines. Was that something that was done on this as well?
Yes.
Was that another early sort of like development, really, as far
yes.
as air conditioning was concerned?
The VC-10 had a Godfrey compressor, which was a separate entity from the engine.
I see.
The Americans at the time didn't like bled air from the engines, but nowadays it's all engine bleed air.
Yeah. So, but you enjoyed working on it?
Oh, it was, yes. It was a unique experience. I'm really glad that we had the option to do it. It was one of those things, years ago we had British fleets with BOAC and BEA, and then American fleet. And it more or less, when you left the British fleet, you carried on with the Concorde. And then when the 747s came in, obviously the 707 guys went onto those.
Yes.
So it wasn't anything, although the rumours were that we were a picked bunch, that actually wasn't the case. It was just a transfer from one fleet onto another, because it was a British aeroplane.
Did you actually get to fly with her as well?
Yes.
How many times did you fly on her?
Over 30. Mainly...
Was that to go to places as an engineer to work on
initially, when we first had the aeroplane in the late 70s, when the crews were doing training, we went as flying spanners. So if it had to divert anywhere, there was someone there who could actually refuel it and, change a wheel, that kind of thing. But lots of the trips were, funnily enough, to New York, which is where the destination was mainly, but there were one or two interesting ones, one of which was the thin lip mod, and they allowed engineers to go up on the training flights on those, and we went negative G. So I've flown around the cabin on this, I've walked on the ceiling in it. It's an awesome experience. But like the Vomit Comet, it's true. It's makes you feel sick.
Really?
Yeah. It was quite interesting, because I can't remember the captain's name, but when we were going to go negative, he actually said, well, lads, we're going negative. Do your seatbelts up. We undid the seatbelts and started flying around the cabin. It's an awesome experience.
Yes.
But the aeroplane was full of things like that. It was different from the subsonics. Different in maintaining it, different in the aspects, different in the way it flew.
Yes.
I mean, I expect Ian said there's no high lift devices on it. It just flew in on the back of the drag curve.
Yes.
So our input really was just in the complicated fuel system and the
maintaining the general aspects of the aircraft.
High input aeroplane.
Yes.
Yeah.
Especially as Ian was mentioning earlier, as the intakes, which were computer controlled, which
yes,
just such a short piece of equipment that's 11 feet long can reduce such a high speed.
Yep.
That's
and
so
yet it
impressive, and all computer controlled.
Yes, and very reliable. Very reliable. In fact, probably the most problems we had, again, was with actually the play on the bearings on the ramps, particularly the rear ramp. an awful lot of work on that. That's where the thrust was felt.
Right.
And changing the bearings and making sure you had the right shims in between to fit it and rig it correctly. That was also one of those Concorde interesting jobs.
So, just one final thing: the mast that's on the top of the fuselage there, is that just a comms mast for radio?
Yeah.
I see. Okay.
That
Definitely not Wi-Fi.
Somewhere.
Well, fantastic, gents. Thank you so much. Glad we got to meet you and got to have a chat with you. Ian, thank you so much. We're going to be meeting up with you again in the simulator in around about 20 minutes, I believe. We're going to have a quick circuit around Surrey from Heathrow, maybe dive bomb Brooklands as well, and have
Fly
some
under
fun in
Tower
there.
Bridge.
I know when we've not got it up running.
Thanks, gents. We'll catch up with you in a little bit, and yes, thank you very much indeed. I appreciate it. Take care.
Okay, thank you. I don't need to clear the throat.
Did it get stuck?
Yeah, it's stopped. I think it's one of the motor switches. Better double your deep, with a hammer. Hammer doesn't sort it, you need a bigger hammer.
Screwdrivers.
Is that all right? Right, there you go. How was that? That was pretty cool, wasn't it? We got there in the end. A little bit of a test card. But other than that, it all went. Let me just see what this looks like on screen here. Yes. So right now, what we're going to do now, folks, is we did actually go out and do a piece with them on the flight deck. Now that's something that you're going to see in the fully edited version. But after this, we actually went to. How long have I got to talk for, Jilly? Okay. What we did later on, about a year later actually, before we managed to square this one up with them, was to put together a piece, because I wanted to get the audio, the mic, we had to run a test to see that the mic would work through the system on board the aircraft, to give it that sort of like a little bit more of an effect. So what we did was we went back after this day to do a piece with them on the cockpit in the flight simulator. Now this is an authentic flight simulator at Brooklands, at the same facility as used by the pilots at some point in time. So it's got everything there, all the batteries and everything, all the systems running in there, and you can actually visit there and go on board the simulator. But as well as that, if you buy, I think it's their gold package or whatever it might be, you get to go to lunch with them. You get to go to lunch with the crews, talk with them, and then you'll see them in action where they've got the first officer and the captain and the flight engineers on board the aircraft. So you can see all the systems as they work, and they are fully authentic. Everything is working and up and running. So that alone takes a lot of maintenance for the volunteers who continually work on the aircraft systems. And of course, as time goes on, these guys are getting older and older, so they're having to train younger people to maintain it as well. So what you're going to see now is a piece that I did many months after the piece that you've just seen. And can you hear me all right? Yeah, you can with that mic. You've got me on mic, haven't you? Yeah, so enjoy this one, folks, and then after that I'll come back again, and then we'll do the we'll do the fully edited version. By then I should be fully and truly cissed. See you there. Bye. 21:57. 21:57. Okay, can I turn the bond off now? Well.
Yeah.
Okay,
Yeah.
well, okay, go live when you like, Julie. Okay, just check audio. Hold standby. You've, okay, Julie, just check audio because you're going to have James through the headset now.
One, two.
Perfect on your headset. Okay, good morning, ladies and gentlemen. We're just going to wait for the audience to gather. As I may have explained to you on earlier shows, we are going to be featuring a live stream flight simulator test on the Brooklands Concorde here in Surrey in the UK. You are more than welcome to join us on this test flight and audio check flight. I'm here with James. Hello, James.
Hi, good morning.
James is the flight simulator engineer for today, who's basically been through how many? What was the size of the procedure? The checklist?
2 pages.
2 pages of checklist just for a flight simulator, just to fire this thing up in the morning. So before we set off, we'll just have a look at this at the panel that we're looking at. James, can you explain what's in front of you there?
Okay, so this isn't too dissimilar from any other kind of aircraft of the time. So you have your basic flight controls and your instruments here. So you have airspeed, artificial horizon, radio altimeter, pressure altimeter, compass and direction down here, and then you have here TCAS, which was retrofitted to Concorde to allow it to continue flying into the States when that was mandated, and that's kind of one of the only upgrades to the flight deck of Concorde over the years.
It's digital equipment on board the aircraft, really, is it? Or,
well, in terms of
display.
digital display on the flight deck, yes. Yeah.
Fantastic. And I understand we've been sitting there for a little while. We've burnt a little bit of fuel, have we?
A few tons, yeah. Probably cost us a fair bit in fuel there. But,
so taxiing from over there, that's Terminal 4, is it? That's where she would have come from.
Yeah. So back then, obviously, they're at Terminal 5 now, but British Airways base and the hub of their operations was from Terminal 4, and the Concorde stand was just down in the cul-de-sac over there next to that KLM aircraft now. And yeah, typically taxiing from there to the runway, around 2 tons of fuel would be burned.
For the more observant of you guys, yes, there are 2 Qantas 747s sitting over there. So we are on runway 27 left. This is the southern runway at London Heathrow. We are. What's the plan for this audio test? And what's the plan for the simulator
Okay,
test?
so the standard test flight we do is from Heathrow. We take off from 27 left. A left-hand turn out to the south to position us downwind on the easterly heading back towards the city of London. We'll then turn in, possibly a little bit of sightseeing over the centre of London, and then we'll come back in and land on 27 left again.
Okay, I believe you might have something special for us when we come back as well.
Potentially, yeah. We'll see how we get on, see how the fuel goes, and make sure everything's working fine.
Good man. Okay, well, we are ready, folks. I hope you're going to enjoy this, because this is a special treat for all of our viewers. Welcome on board Concorde. Here we go.
Okay, so the before takeoff checklist. So as I said, we're going to take off. We'll climb up to 17.5 degrees nose up. Climb, once we're above 500 feet, we'll make a gentle left-hand turn out to the south. Then we'll continue that turn around onto an easterly heading. Our V1 speed is just above 160, rotate is 195, and then we're looking at V2 around 220 knots. Landing lights are not required, the transponder is set, wheel light is out, takeoff monitor is armed. The reheats, so that's going to give us that 25% extra thrust for takeoff. Then armed, you see the 4 white lights there to confirm they're primed, ready to kick in when we open the throttles. Pitch index is set at 17 degrees, and that is cross-checked. Radar is as required, brake fans are off. Gear override push button is done, and the before takeoff checklist complete. So, are we ready?
We're ready, sir.
Okay, so brakes released. 3, 2, 1, go. Okay, so you see the engine instruments are starting to react to power that's building. Using the rudder pedals to keep on the center line. So we have airspeed building both sides. 100 knots, power checked. Okay, so there's V1, the point of no return. We're committed to take off V1. Okay, rotate, so I'm going to pull back and pitch up to 17.5 degrees. Okay, positive climb, the gear is coming up. The noise abatement, so we'll cut out the reheats and just bring the power back. It's 500 feet, so we'll start that gentle left-hand turn. Okay, so we're climbing just under 2,000 feet a minute now, going through 1,600 feet. We'll put the auto throttle in now to take care of the speed for us, 250 knots. So you should start to hear that build in a second. And we'll climb up to 2,000 feet to begin with. Okay, so that's south. We'll keep the turn going now. Just checking that all of the instruments are reacting as they should be, which they are on both sides, so that's good. So we're coming out, we're going to roll out onto that easterly heading, 090 degrees. That will put us downwind, so Heathrow is just off to our left over there now. Okay, and we'll settle then at 2,000 feet for a second. And you can just see the Shard and kind of central London's coming into view over there. Okay, so 2,000 feet, we are level off there. The auto throttle will maintain our speed for us, and what we'll do now is we'll do the nose and visor. So we'll bring the nose up to 0 degrees first of all. It's at 5 degrees of takeoff, so the nose comes up. And then once that's up, we'll bring the visor up as well. Okay, and with that then we'll take the auto throttle out and we'll just accelerate just to our VMO, our maximum operating speed for this altitude, and then bring the power out again. So we're accelerating now to 300 knots. And because of the speed coming up, you can see it's now climbing, so we're climbing at nearly 4,000 feet per minute. Bring the power back just before we get the overspeed warning. Okay. And then we'll come back down to 250 knots. So auto throttle will take care of that for us. With London on the nose there, so you can see just over there's Hyde Park, the Shard, the London Eye, Canary Wharf over there. So, okay, so speeds come back, so we'll bring the nose back and visor back down to 5 degrees. You can see Battersea Power Station is down there. If we just dip down, you'll be able to see there. For the O2 and Canary Wharf coming into view over there as well. And nose back to 5 degrees. And what we'll do now, we'll descend down low and we'll just make a low pass over London so you can have a quick look, and then we'll head back to Heathrow. The London Eye, Big Ben just down there. There's the Mall and the Buckingham Palace just ahead as well. So we're heading now kind of southwest, and you see Heathrow is just over there, kind of 1 o'clock. So that's 27 right we're passing through now, and in a second we'll come to turn onto the localizer for 27 left. Okay, so I'm going to start the turn in now. I've got the localizer bar there indicating that we're in the right place. We're a little low because of our low pass, but it's not a problem. Okay, so the speed will come back to about 190 knots, which is still quite fast for an approach speed compared to kind of other commercial aircraft. Typically it'd be around 160 knots for now, until around 4 miles out, and then they would slow down. So we'll bring the nose down, and we'll take the gear out now. And so glide slope is telling me I'm a little bit low there, so we didn't climb up again after our low pass through London. So we won't descend anymore. We'll just keep the nose up to stop our descent going any further down. There we go. So we're about just under 6 miles out now. So we have the gear is down with the greens, we have the nose and visor down. We're at 190 knots, so we'll keep that until around 4 miles out, and then we'll slow to about 165, which again, still significantly faster than other aircraft at landing. Okay, so 2 red, 2 white, so we're just going to follow now those lights down and fly the approach using those as a reference. time, gear up. So it's a right-hand turn out to the north, and then we'll just come round and do a tight circuit to land again. So probably passing over kind of Slough and Colnbrook now, I'd imagine. That will be Northolt over there, yeah.
Good old M25.
Not a lot of traffic
Looking
today.
a little bit empty.
Yeah. Okay, so we're back on that easterly heading. You see London again ahead of us. There's Heathrow just out over there. So again, we'll just go out to about 6 or 7 miles and then turn around and come back in again. Bring the speed back to 220 knots. Intermediate approach should be there before we select 190 for the approach. Okay, so the glide slope is alive. We're at just under 7 miles, so we'll turn in now. Again, just over Kensington here in West London. There's Hyde Park over there. And we'll just keep this right-hand turn round and bring us round onto 27 left to Heathrow.
Knots is your approach speed, is it?
Correct, yeah. So then we slow down to about 165 a few miles out. So. Okay, so there we are. So we head on that heading. That's putting us southwest, and then we'll turn gently on to final for 27 left. Okay, so the gear is coming down. I'll take the nose down as well.
Nice one.
Knots, we cancel the reverse and then just on the toe brakes to come to a stop.
Wow. Fantastic.
And there we are.
Thanks so much, James. Really appreciate that. I'm sure everybody else does as well. No doubt there's a few thousand comments to be coming onto the stream at some point over the next couple of days and today as well. So listen, thanks very much indeed. I think that was a successful test, most definitely. And thanks so much for helping us.
How cool was that, folks? And thanks very much to can't remember his name, but he's one of the guys that works there at Brooklands, and you can get a tour with him around that area. The reason why we had all that glitching was because the actual building that the simulator is in is fully encased in concrete. It's brick. And then you've got the simulator itself, which is housed inside steel. So obviously the signal was a little bit dodgy inside there. Actually got away with it quite well, to be honest with you. Right, next one. Now this is interesting. I know a few of you guys are like, right, you know, I've got to go out for the evening or whatever it is you've got to do. It's Friday night, isn't it? Is it Friday night? It is, isn't it? But where are you going to go? Where are you going to go? You can't go down to Boozer, can you? Well, yeah, but would you want to go? Would you want to go down the pub? It's the last night to go to the pub. Well, yeah, don't go to the pub, man. Honestly, I just wouldn't, even though it's the last night, I just wouldn't go. I just wouldn't. Just be careful. Be safe, folks. Anyway, listen. Now we're going to cut to the fully polished version of the live show. So there's a lot of stuff that I've linked into this. A lot more informative, a lot cleaner, and all that stuff going on. It's very clean and tidy. So we run through the whole thing. Enjoy this, and after this we're going to cut, and then we will see you tomorrow up on the roof. Up on the roof. Tomorrow afternoon, around about 2 o'clock in the afternoon, for what is possibly, most definitely for the foreseeable future, for the time being, the last ever Air New Zealand flight out of London Heathrow to Los Angeles, because the plan was, before all this CV-19 crap, that this was going to be this service was going to be cancelled from September, around about September of this year. However, unless this clears up quickly, which we're hoping it will, which I'm being optimistic that it will. And to be honest with you, I have spoken with a number of aircrew, because I am in contact with aircrews, and they are very optimistic that we're looking at 2 months, folks, 2 months, and maybe even as little as 30 days before things start to improve slowly but surely. But obviously, airlines will need to invite people back in by way of reducing their ticket prices and so on and so forth, to fill their planes and get everybody back in the sky again. And you'll see air travel moving very, very quickly. And this time in 6 months, we'll be all saying what a terrible time it was. But we all got through it together. One community in general that got through it together was us on Big Jet TV, amongst with all the other av geeks and aviation fans around the world. So glad to bring it to you, folks. This is the final edit of Brooklands Concorde at Weybridge in Surrey. A lot of people were asking me where the aircraft is based, and that's Weybridge in Surrey. Look them up, folks. Brooklands Museum, Brooklands, Brooklands Museum. Very famous place, steeped in history, where the Wellington bombers were actually made as well, or assembled, should I say, and flown out of there. So a lot of history with that, with Concorde, with Barnes Wallis as well. Of course, the man who built the the upkeep bomb, the bouncing bomb, as well as the tall boy, the earthquake bomb, amongst lots and lots of other stuff. They've got a huge wind tunnel facility there, and it's an old school one as well. Really good to visit there, folks. Take the kids up there, and if you're into buses as well, they've got a whole separate bus museum as well. And of course, steeped in massive history is the big Brooklands circuit as well, the oval, which they still have certain sections of there. If you look on Google Earth, you can actually see the oval, but there is a very small section of the banking which is still there right by the museum, and they've got some amazing cars in their museum with all the original workshops, a great cafe. It's just a great place to visit, very reasonable in terms of the pricing as well, and of course they've got Concorde on display as well as other aircraft. You saw there VC-10 with was it Air Zimbabwe, I think, that one. Those aircraft were flown into this facility as well, folks. The only one that wasn't, I think, was indeed Concorde. Correct me if I'm wrong there, but they do have other aircraft there as well, BAC 111 I believe, as well as other aircraft that you can go on, you can get inside. The cockpits get really tight up into it, and enjoy your time there. Take the kids there, or just a day out with a missus, or on your own if you fancy it. But anyway, this is the edited version. Enjoy it, and I'll come on the feed now. And thanks very much for watching, folks, and we'll see you up on the top of the roof tomorrow around about 2 p.m. for that Air New Zealand departure. Thanks for watching, folks. See you in a little bit. Cheers, bye.
Hello everybody and welcome to a very special show here at Brooklands, Surrey in the UK. Today we'll be showcasing Concorde Delta Golf, going around the aircraft with flight engineer Ian Smith. But before we do that, let's get some history on the aircraft with Concorde lead trainer John Carter.
Concorde is very closely linked to Brooklands. One of our most celebrated engineers, Sir Barnes Wallis, was working here with Vickers, and he started to experiment with supersonic flight. Indeed, he built models here which were destined to fly supersonically. The other work that Barnes Wallis did was associated with aerodynamics, in particular in relation to the engine intakes, where the air has to be slowed from 1,350 miles an hour to 500 miles an hour within 11 feet in order for the engines to operate efficiently. As we moved into the development phase of Concorde, the French and the British governments agreed to collaborate in the development of Concorde, and the first meetings of the teams to develop that aircraft took place in Paris and here at Brooklands in 1961. So from then on, a lot of the design work was done here, and as we moved into the development phase of the aircraft, the teams agreed that production of the parts for Concorde would be split between the two teams. Certain bits of all 20 Concordes were built in the UK, and the other bits were built in France. The teams then swapped those pieces to the two construction sites, Filton for the British Concordes and Toulouse for the French Concordes. And 30% of the airframe of all 20 Concordes were built right here at Brooklands. And that includes the 90 miles of wiring that every Concorde contained. So that is why Brooklands has become known, in our view, as the home of Concorde. Delta Golf was the first of the 8 British production Concordes, but she never actually went into airline service. Instead, she was used for 3 very special purposes. First of all, she was a demonstration aircraft. She flew around the world demonstrating Concorde to airlines and governments. Secondly, in the summer of 1975, Delta Golf was used as a training aircraft for the first generation of British Airways Concorde pilots. And lastly, Delta Golf was the Concorde that did most of the test flying to obtain the certificate of airworthiness. In other words, its license to carry passengers. And it was during that phase of her life that Delta Golf has become truly immortal, because she was the first Concorde and therefore the first aircraft in history to carry 100 passengers at twice the speed of sound. When Delta Golf was taken out of service in 1981, she was taken to Filton, and she was acquired by British Airways in 1983 and was essentially used for spares. When Concorde was taken out of service in 2003, British Airways gave Concorde to the museum, but she had to be cut into 5 pieces and transported from Filton to here, and over the course of 3 years, together with our team of engineers and a contractor, we put her back together again into what you see today.
So thank you to Concorde lead trainer John Carter there, giving us some great history on the Brooklands Concorde. Now we're going to be meeting up with Ian Smith, who was a flight engineer on the Concorde, and he's going to be walking us around the entire aircraft, inside the cabin and up to the cockpit. This nose right at the tip was around about, what was it,
127 degrees centigrade. That was the limit. The reason they chose that was that the aircraft was built out of aluminium-based alloys, and to give a reasonable fatigue life, they had to restrict it to that speed so as it wouldn't overheat and then reduce the fatigue life. Yes, the noses, they could reach 127, and if we were cruising along in supersonic flight, if it tried to go above that, if the autopilot was flying it, it would automatically slow the aeroplane down to bring it back to that limit. That was the factor involved in that Mach 2 speed.
You've got some deflectors there.
The reason they had that is when the aeroplane was flying at low speeds, sort of below 250 knots, say, it was to channel the airflow down and make the airflow closer to the fuselage so as the rudders became more effective.
Now, one of the big things that is quite apparent is the fact that you are around about 30 feet from the cockpit to the nose gear, resulted in a huge turning circle.
Look at the VC-10 just behind Concorde. See where the nose wheel is that compared to the flight deck, the cockpit of that. So when you're taxiing and going round corners and things, you were sitting near the front of the aeroplane. On Concorde, when you come back to this and you see the distance,
yes,
the pilots actually went right over the grass to turn.
Yes.
Because it's so long out there to the flight deck, if we are taxiing on a sort of slightly rough taxiway or even in the runway, if you were down the back of the cabin and looked all the way up to the flight deck, you could see us bouncing up and down at the front of the aeroplane. Although it's an aluminium-based alloy, it's slightly different to other materials that were used in aircraft, but it was still effectively low cost or lower cost than going to things like stainless steel and titanium.
And of course, such a high undercarriage.
Yes, the whole undercarriage, the mains as well, had to be off the ground, because as you rotated to come off the ground, and the back of the aeroplane came very close to the ground, it's a totally different aerodynamics compared to a subsonic wing. The shape of it changed quite considerably. You might just catch along the leading edge the way it curves up and down.
Yes, yes.
It's three-dimensional. You see how thin the wing is at the outer part there? That's actually a fuel tank as well. All that wingtip contained 2.5 tons of fuel. So the designers did an amazing job, which is really a very tiny aeroplane with a lot of little tanks, 13 fuel tanks in this thing. As the aeroplane accelerates, the centre of lift moves rearwards in the wing. So what we did, we moved fuel to alter the centre of gravity, so it just matched the centre of lift movement in the wing. When we are at 190 knots, say in the outer approach, we were using the same amount of fuel as we did cruising at twice the speed of sound.
I believe this was a skid on the initial aircraft.
The very first one was a skid, and then the next one had the little wheels and it had this concept. If we're training new pilots, the very odd occasion you'd maybe see the little wheel marks. This is a vastly developed engine. The original engines, I think they developed maybe probably about 12,000 pounds of thrust, and then they gradually increased to 20,000. The reason they chose this engine was that in supersonic flight, a jet engine will only accept a supersonic airflow up to about 1.5 times the speed of sound. We had to slow it down, so we had this intake in the front to reduce that. In 11 feet of intake, it goes from twice the speed of sound to half the speed of sound. For the thrust we required on takeoff, it would really have meant we had to carry an extra engine. So we resorted to the reheater afterburning. All it really was injecting fuel at the back of the engine, lighting it up, expanded the air a bit more and gave us the extra thrust. We sprayed fuel in, and the flame attached to this gutter, they called it, held the flame alight and working for the reheat. This is the rear cargo door, and that's the bulkhead. This part here is where the galley would be. The rear doors were in the galley area, these doors. When it came to the museum, this was really just a shell, so they decided to put certain things on display. These are the airlines that were going to buy Concorde.
Yes.
Well, a lot of these airlines decided they weren't going to go to the expense of it. Here you can see the example of the seating. It was a small aeroplane, but it had to be this size. It couldn't be like a jumbo jet to fly at these speeds. We wouldn't have put 100 seats in it.
This nose fairing actually came off the one at Filton, so there was an accident at Heathrow. So DG donated her nose, the one that's now at Filton, and this is the one at Filton. But it was halfway through being refurbed when she stopped flying. So all the systems in the movable part of the nose down there wasn't there. So we had to effectively recreate all of that. Everything in kind of the fuselage structure, so everything under the floor here was still there. The procedure for this specific aircraft is slightly different, that we have to pull the emergency release handle to get the nose down. But shall I just go through it now then? Shall I start?
Most
Right,
definitely. Yep.
So first you need to turn hydraulic pressure on, and then it works as per it should do from the normal nose and visor selector valve.
So that goes into the nose.
So yes, at this point I'd be able to just go to the next section, which is nose 5 degrees, and then the nose comes down. So there should be a nice click. Sure is.
Okay.
So this is the point where she was misbehaving, and she's working this morning. There we go.
We had to comply with various air traffic instructions and things.
Yes.
But if we went above 270 knots, that's 300 miles an hour, then we streamlined the aeroplane. We put the nose and visor up, and it became fully streamlined. And then, of course, as we slowed down through 300, we put it all down again.
Yes.
So we went to the mid position, as James had mentioned there, 5 degrees with the visor down, and then just before landing we'd pop the nose fully down. Final approach, but the pilot would be flying about 10.5 degrees nose up attitude, so you wouldn't see over the nose.
Well, thank you to Ian and John and James, of course, for showing us around Delta Gulf. And, of course, great to see that nose still working after all these years. And congratulations to James for making that happen. Now we're going to go on board the Concorde simulator here at Brooklands, meeting up with Ian again. So let's go fly.
So So all the checks were completed, and we wait, get the air traffic clearance, and there we'd go. So that's the throttle's been pushed fully forward, the engines would power up, the reheats would light up, and the aircraft would accelerate. About 100 knots, we should have a check of all the engines. There was a little green light for each engine, would tell us we'd full power. We'd get to the decision speed V1. If we had a failure before that, we would stop. If the failure was after, we'd take failure into the air and sort it out then. We get to the point, rotate, pilot pull the control column back, and on our instruments we'd pitch up to a preset position, and the airplane would rotate and climb away. In the Atlantic, between the positions, the waypoints in the Atlantic, at a subsonic aeroplane it's about an hour between these points. On Concorde it's 20 minutes. So during that time there's various checks to be done. So you are actually working virtually the whole time during these flights.
Okay.
It's not one of these aeroplanes, you get airborne, put the autopilot and then read the paper.
Yes.
It's an aeroplane you had to monitor the whole time.
Yes, yes, right.
During the cruise, we mentioned the flight engineer moving fuel.
Yeah.
That was mainly during the acceleration up to supersonic speeds.
Yes.
But in the cruise, we trimmed the aeroplane. We had an instrument down in the bottom that showed where our flying controls were positioned.
Interesting.
And we moved fuel to position that in the most streamlined position, because that was the least drag, more fuel efficient. So we pumped fuel fore and aft and left and right to keep the controls in the streamline. The Concorde was a very controllable aeroplane. The performance, that, for example, taking off from New York with a very special noise abatement procedure. And we could achieve that because the aeroplane was so controllable. And on automatic landing, because the engines are controlled electronically, and because the flying controls are electronic, fly-by-wire, it was very smooth and with little wings. So you crosswinds didn't have a huge problem. We always took off full power. The aeroplane is actually just above landing weight. It's a very light aircraft.
Wow.
What we would do is we would fly a circuit and overshoot, not touch down, and then the next one we would land. So the aeroplane was light, full power. It really went off like a scalding cat. The pilots there, the idea of circuit height, 1,500 feet.
Circuit height 1,500 feet.
The training captain always got clearance above that. I won't tell you what the record is how high we've got in the past, but we often exceeded that in the first takeoff.
Wow.
Because it was a case of you got off the ground, you got to 250 knots, and you got the reheats off, throttle back.
Yeah.
You had to nail it.
Yes.
So things happen much quicker. So to get the pilot, although you'd been in the simulator and you'd done all this couldn't replicate with the real airplane.
Yes.